Hey mathematics learners, welcome to Distance Learning with Lee, where I make learning mathematics super easy. On today's video tutorial, guys, we are going to be having a look at the last question from the grade 12 mathematical literacy paper 2 that was written by the Gauteng province learners, right? And in today's video tutorial, guys, we are going to be looking at question 5.1 and question 5.2. Okay, so question 5.1, we are basically going to be looking at this BMI chart that is given to us here, and then we are going to be using it to answer questions that are given, right? And in question 5.2, guys, we are given a strip chart, so we're going to be analyzing the strip chart, and we're going to be answering questions given to us based on calculating the average speed given the distance and the time, right? And also calculating if Mr. or Coach Maxwell will have to then refuel his car, given the amount of fuel that his car consumes per 100 kilometers. Okay, so before you get started with today's video tutorial, guys, please make sure that you are subscribed to the channel. Please make sure that you click on that notification bar so that you get notified every single time I upload a video tutorial, guys. And also don't forget to give this video tutorial a huge thumbs up, because that really helps the channel grow and it helps the channel to reach more learners that want to better their mathematics marks. So without any further ado, guys, let's get started with today's video tutorial. Right, so like I mentioned, we are going to be tackling question 5.1 and question 5.2. Question 5.1, we are going to be analyzing a BMI chart, right? And we're going to be using that chart to answer questions that are given to us, right? So let's have a look here. Question 5.1 says that study the percentile chart in Annexure C and answer the questions that follow. Coach Maxwell, the trainer at a local athletics club, uses percentile charts to determine the health status of athletes who are joining the club in order to determine the best exercise for them, right? Coach Maxwell allows athletes whose BMI are between the 5th and the 85th percentile to join the club. So we are basically told that this coach, right, uses a percentile chart to determine the health of the athletes who are joining the club, right? So just quick, basically give you guys info on what BMI or the body mass index actually tells you is that the BMI basically gives you a person's weight in kilograms, right, divided by the person's height in meters squared, right? So if a person has a high body mass index, right, that basically indicates that that person has high body fat. Okay, so that is basically what is happening here, right? And we are told that Coach Maxwell, allows athletes who have a body mass index between the 5th and the 85th percentile to join the club. Okay, so we're going to be using the percentile chart to help us basically answer the questions that are given to us. All right, so let's have a look at question 5.1.1. What does the abbreviation BMI represent? Okay, so like I've already mentioned, BMI basically stands for body mass index. Okay, did I just say max or mass? Okay, so BMI stands for body mass index. All right, let's have a look at the next question. Question 5.1.2, determine the maximum body mass index that a boy should have to be able to join the club, right? So we are told that the coach allows athletes whose BMI are between the 5th and the 85th percentile, right? So here we can already see that the 85th percentile will be the larger percentile, right? However, this is just the percentile. We still need to determine what the maximum BMI will be, right? So here we need to basically use the charts that is given to us to help us determine what the BMI is going to be. So let's just have a quick look at this chart here and see what is given to us. Okay, so this chart basically has or represents the age in years in your x-axis, right? And then on your y-axis we have the BMI values, right? And we can see here that it shows that your units of measurement for your body mass index, right, is kilograms per meter squared. Okay, so if we already know that the maximum percentile is the 85th percentile, what would then be the body mass index for the 85th percentile, right? So here we are just going to read off the BMI value from your y-axis here, right? And we see that here, this line here basically represents the 85th percentile, okay? So that means that the BMI for the 85th percentile it's this value here between 26 and 28, right? And that value we can just see is 27, okay? So that is the value that we want here, okay? And then it is 27. So it's 27 kilograms per meters squared, okay? So to answer the question, determine the maximum BMI that a boy should have to be able to join the club. We found that the maximum BMI that a boy should have to be able to join the club is 27 kilograms per meter squared. Okay, next question. Question 5.1.3. Hence, determine the maximum weight of a boy who is 1.8 meters tall and whose BMI is considered healthy for a boy athlete, right? So when you see a question that basically says hence, okay, this basically tells you that you need to basically use the answer that you've obtained in the previous question, right, to answer this question, right? So in this case, we already found out what the maximum BMI was here, right? And we found that to be 27 kilograms per meter squared, okay? So we're going to use this BMI that we've obtained in our question 5.1.3. Okay, so in this case, we were given the height of this boy, which is 1.8 meters, right? We already know what the BMI is, which is 27 kilograms per meter squared. All we need to do here, guys, we need to basically just determine what the maximum weight of a boy, okay, who's considered healthy. Okay, so let's basically write that equation down. Okay, so the equation says that BMI, right, is equal to the weight in kilograms divided by your height, okay, and your height, right, is in meters squared, right? Okay, so here we're basically going to substitute all the values that we already know, okay? We already know what the BMI is, and the BMI is 27 kilograms per meter squared. So I'm going to write the per meter squared in this way so that you guys will be able to see which units are canceling, right? Which is equal to, this is your weight, which is the value that we want in kilograms divided by your height. So in my explanation of what a BMI is, right, I explained that when you basically calculate a person's BMI, right, you basically take a person's weight in kilogram and then you divide that weight by the height squared in meters. Okay, so in this case, this height of 1.8 meters needs to be squared. Okay, so it's 1.8 meters. This needs to be squared. All right, so all that we basically need to do now is we need to isolate the weight because that's what we're trying to obtain. So we can isolate it by doing the reverse operation of division, right? So what is the inverse of division? It's multiplication. So we're going to multiply by 1 point. Okay, so we're going to basically multiply the right hand side by 1.8 meters squared, and what you do on the right hand side you also need to do on the left hand side, right? And then what happens here, you see that whatever units you're going to get here is going to be units in meters squared. So let me just show you. If you punch in 1.8 into your calculator, you will actually get, if you punch in 1.8 squared into your calculator, you'll actually get 3.24, right? And it's meters squared multiplied by 27 kilograms divided by meters squared, okay, which is equal to the weight. Okay, So all that we need to do now, we just need to punch in all the values into our calculator. And if you punch this into your calculator, you'll find that the weight of a healthy boy athlete who has a height of 1.8 meters and a BMI of 27 kilograms per meter squared is equal to 87.48, right? And the units for weight is kilograms. Okay, right. And we are basically done with question 5.1.3. Question 5.1.4 says that a 14-year-old boy who weighs 48 kilograms and whose height is 1.3 meters claims that he qualifies to be admitted to the club. Calculates the BMI of the boy, right? So we're not trying to verify if this boy qualifies to be admitted to the club. The question just wants us to determine what the BMI of the boy is, right? So here, still very easy and easy 2 marks, right? Because we are already given the weight of the boy in kilograms, because we're already given the height of this boy in meters, all we need to do is we need to substitute these values into the given formula for us to basically determine what his BMI is. Okay, so let's just quickly do that. Question 5.1.4. Okay, I'm gonna do this here. Okay, we already know that BMI is equal to the weight divided by the height. Okay, so I'm actually gonna write it like this so you guys know it's the height squared. Okay, right? The units for the weight is in kilograms. Units for your height is meters squared. Okay, so if you punch these values, substitute the given values into this formula, we're given that his weight is 48 kilograms and we were given that his height is 1.3 meters. So the height needs to be squared. Okay, so if you punch this into your calculator, you'll get that this boy's BMI is actually equal to 28.40236686, okay, kilograms per meter squared. Okay, then if you run this answer off to 2 decimal places, you'll find that this boy's BMI is actually equal to, okay, 28.40 kilograms per meter squared. Okay, so then we're basically done because they just wanted you to basically determine what his BMI is. They didn't ask you to basically verify whether he can be admitted to the club. Right, so that is it for question 5.1. Quickly, let me show you guys how they will mark this question, right? For question 5.1.1, you'll literally get 2 marks for saying that your BMI stands for your body mass index. 2 marks. Question 5.1.2, right? You will basically be given 2 marks for basically reading the BMI from your graph, right? This is out of 2, so it's 2 marks now. Question 5.1.3, you'll get 2 marks for the correct substitution of 27 kilograms per meter squared. Another mark for substituting your height squared, right? You'll get another mark for multiplying these two values together, and your final mark for your final answer of 87.48 kilograms. So that is out of 4 marks. Okay, and question 5.1.4, right? You will get a mark for the correct substitution of the values into your formula, just 1 mark for that, and you'll get a final mark for the final answer of this boy's BMI of 28.40 kilograms per meter squared. So that is out of 2 marks. So this question 5.1, was basically out of 10. Okay, and it's basically an easy 10 marks because we are just basically reading off values from the charts, and we're also substituting values into the given formula, right? So where they would probably catch you is where you basically calculate your height. Okay, you were supposed to basically see that if your height is meters squared, that means that the value for the height that you are given, you basically need to square that value. All right, so that is it for question 5.1, guys. Let us have a look quickly at question 5.2, right? Like I mentioned, question 5.2 is a strip chart, right, that basically shows a distance from Cape Town to Bloemfontein using the national road. Okay, so let's have a look at the questions that are given to us. Question 5.2, use an extra D to answer the following questions. It says that Coach Maxwell is traveling from Cape Town to Bloemfontein, right? We need to determine the distance from Colesberg to Beaufort West. Okay, so we're going to basically have a look at the strip chart that is given to us, right? And we want to basically determine what is the distance between Colesberg and Beaufort West. Okay, so I'm just going to quickly highlight where Colesberg is. So that is Colesberg. I'm going to quickly highlight where Beaufort West is. That is Beaufort West, right? So we want the distance between Colesberg and Beaufort West. Okay, so please take notes. If you are basically moving from Bloemfontein to Cape Town, you need to basically read off the kilometers on the left hand side of your strip chart. If you're moving from Cape Town to Colesberg, you need to basically read off the kilometers on the right hand side of your strip chart. Okay, so in this case, here, if you to basically get the distance between these two towns, you can either say 778 kilometers minus 440, okay, because we can see that Beaufort West is 460 kilometers from Cape Town, right? And Colesberg is 778 kilometers from Cape Town. So we can just really take the 778 minus 460 to get the distance between those two towns, right? Or you can just simply look at your kilometers on the left hand side, right? What is the distance of Beaufort West? Beaufort West is 544 kilometers from Bloemfontein, okay? Minus, okay, Colesberg is 226 kilometers from Bloemfontein, okay? So you can either take 778 minus 460 or 544 minus 226, and those values will basically give you the distance between Colesberg and Beaufort West. Okay, so I'm going to take 778 kilometers minus 460 kilometers, right? If you punch that into your calculator, you'll get that the distance between these two towns is 318 kilometers, okay? Or I said that you could just say 544 kilometers minus 226 kilometers, right? If you punch that into a calculator, you'll still get the same distance of 318 kilometers. Okay, so either one of these answers will be accepted. Question 5.2.2 says determine the probability of driving through or past a town starting with the letter T along the N1 from Cape Town to Bloemfontein. Okay, so with this question, we are told that we are basically driving along the N1, okay, from Cape Town to Bloemfontein, okay, and then we basically need to determine the probability of passing through or along towns that basically start with the letter T. Okay, so what I'm going to do here, I'm going to start off by highlighting the towns that start with the letter T between Bloemfontein and Cape Town. Okay, so I see that here as I move along the N1, okay, these are the towns that I'm seeing. It's Springfontein, it's Colesberg, it's Hanover, okay, it's Three Sisters. So that's the first town that starts with the T, right? It's is it Linesburg, and then it's Toes River. That's another town. Okay, is it Worcester? Okay, then we see Worcester, Paarl, right? So those are the towns that we can see here. So we basically saw that the towns that we would be passing through or pass along the N1 if you're moving from Cape Town to Bloemfontein that start with the letter T is two towns, right? And then what are the total number of towns that we see here? Okay, so the towns here, we basically see the towns. The towns are basically denoted by this circle here. Okay, so when we see this circle, that basically means that we're passing a town. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 total towns, okay, that we would be passing through or past, right, along the N1. Okay, so when we're basically calculating probability, guys, you should be able to calculate probability at this point. Probability is equal to your favorable outcomes divided by your total outcomes, right? So what are our favorable outcomes? The favorable outcomes is passing through or past towns that start with the letter T, right? So we found that those towns, how many towns are those? It's two, okay? So let's just quickly write that down, okay? So the probability of passing towns that start with the letter T is equal to your favorable outcomes divided by the total outcomes, okay? Okay. So the favorable outcomes, what do we want? We want the towns, okay, that we will be passing through or past, right, that start with the letter T, okay? So in this case, how many towns did we find here? It was two, so it's going to be 2 divided by, what are the total outcomes? How many towns are along the N1 between Cape Town and Bloemfontein, right? So if we basically count the number of towns we have along the N1 between Cape Town and Bloemfontein, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 towns. Okay, so those are the total outcomes. Okay, so therefore the probability of driving through or past a town starting with the letter T is equal to 2 over 9. Let's have a look at the next question. Question 5.2.3. On his way from Cape Town to Bloemfontein, Coach Maxwell stopped at Lanesburg for 45 minutes to have lunch. His next stop was Beaufort West, right? So he stopped at Beaufort West for 15 minutes, and then later he stopped for 15 minutes at Colesberg. The trip from Cape Town to Bloemfontein took him 9 hours and 15 minutes in total. We need to calculate the average speed to the nearest kilometers per hour at which Coach Maxwell traveled from Cape Town to Bloemfontein. Okay, and you need to justify by calculation whether he kept to the maximum speed limit of 120 kilometers per hour on national roads. And then they basically told us that we may use the following formula. So we basically given the formula on how we can basically calculate the average speed. And we told that the average speed is equal to the distance, right, in kilometers divided by your time. Okay, so here we're not told the units that you need to use for your distance. You should know that the distance, right, when you're calculating average speed, needs to be in kilometers, right? And the time needs to be in hours, right? Because we're trying to basically compare this average speed value to this maximum speed, right, that he needs to basically keep to if he travels on the national roads. Okay, so that is basically how we know what units we're supposed to use in our formula. Okay, so how do we go about this question? So we already know that the time that Coach Maxwell spent, okay, traveling from Cape Town to Bloemfontein was a total of 9 hours and 15 minutes. Okay. However, we want to basically determine how much time or the speed that he traveled, right, on the national road. So how will we be able to basically determine that speed? Okay. We need to first determine the time that he spent stopping. Okay. Once we determine the time that he spent stopping, okay, on the different towns that were given to us here, Lanesburg, Beaufort West, Colesberg, right? We will be able to basically minus that time spent stopping to the total time of his trip, right? And then from there, we will be able to now substitute the total distance that he traveled from Cape Town to Bloemfontein to the total time that he actually spent traveling on the road. Okay, so that is basically how we need to approach this question. After we've done that, we will be able to determine the average speed that Mr. Maxwell then spent on the national road. Okay, so let's basically first start off by calculating the time that he spent stopping. Okay, so the time that he spent stopping, right, is basically equal to the 45 minutes that he stopped at Lanesburg plus 15 minutes that he spent stopping at Beaufort West plus 15 minutes that he spent stopping at Colesberg. Okay, so it's going to be 45 minutes plus 15 minutes plus 15 minutes. Okay, so in total, he spent a total of 75 minutes stopping. Okay, so we're going to have to now convert these minutes into hours because the units for our time is in hours. Okay, how will we convert these 75 minutes into hours? We already know that 1 hour, right, is equal to 60 minutes, right? So what basically this means, for us to convert these 75 minutes into hours, you're going to multiply by what we want, which is our units in hours, divided by what we have, which is the units in minutes. So if you punch that into your calculator, you'll find that 75 minutes in hours is actually equal to 1.25 hours. Okay, so he basically spent 1.25 hours stopping. Okay, so now we need to now basically determine the total time that he spent on the road. Okay, so to get the total time that he spent on the road, okay, we are going to take the time that he spent, the total time that he spent, or the total time for his whole trip that was given to us of 9 hours and 15 minutes, and we're going to subtract the time that he spent stopping of 1.25 hours. Okay, however, we notice here that the time that he basically spent traveling from Cape Town to Bloemfontein is actually given as 9 hours and 15 minutes. So we basically still need to convert those 15 minutes into hours before we can now plug them in, or plug this in into our equation. Okay, so let's just quickly convert this 15 minutes into hours. I'm going to do it here. We want to convert 15 minutes into hours. So still, if you want to convert minutes to hours, you're going to multiply. We are still using this conversion here. Okay, you're going to multiply by what you want, which is your units in hours. So it's going to be 1 hour divided by what you have, which is your units in minutes, which is 60 minutes. Okay, so if you punch that into your calculator, 15 minutes converted into hours is equivalent to 0.25 hours. Okay, so now we basically know what is the total time that you spent traveling from Cape Town to Bloemfontein. We know that it's actually 9 hours 15 minutes. I'm just going to write it like this first, right? Minus, right? What is the total time that he spent stopping? We found that to be 1.25 hours. However, I said that we need to basically convert these 15 minutes into hours, okay, so that it makes our lives easier, okay, so that we know that we just have the units in hours in total. Okay, so 9 hours plus 0.5 hours is the same. 9 hours 15 minutes is the same as just saying 9.25 hours, because 9 plus 0.25 is equal to 9.25. So 9.25 minus 1.25 hours, right? That will basically leave you at 8 hours. Okay, so the total time that the coach Maxwell spent on the road on the national highway actually was 8 hours. So all that we basically need to do now is we need to basically substitute this total time into our formula, and we also just need to get the distance that he basically traveled from Cape Town to Bloemfontein, and then from there we will be able to determine the average speed that he traveled. Okay, so let's just quickly do that. What is the distance that he basically traveled from Cape Town to Bloemfontein? So if you start from there, go all the way up until there, you'll see that the total distance that Maxwell traveled from Cape Town to Bloemfontein is 99 kilometers. Okay, so all we need to do now, we need to substitute these values into our formula to basically determine the average speed. Okay, so therefore our average speed is equal to your distance divided by your time. Okay, then we found that the total distance from Cape Town to Bloemfontein is 999 kilometers, right? The total time that he spent driving is equal to, actually, let me write total time spent driving. Okay, I think that makes more sense. Okay, so the total time spent driving, we found that to be 8 hours. Okay, so if you take 999 divided by 8 hours, you will find that he actually, okay, you will find that his average speed was 124.875 kilometers per hour. So that was his average speed, or the speed that he was traveling at on the national road. However, what is the question basically asking us? It was asking us to calculate his average speed, okay, at which Coach Maxwell traveled from Cape Town to Bloemfontein. We already found what the average speed is, okay? A second part of the question says that justify by calculation whether he kept to the maximum speed limit of 120 kilometers per hour on national roads. Okay, so the answer that we've basically obtained here basically tells us that the coach Maxwell didn't keep to the maximum speed limit, because what we can basically see here is that the maximum speed limit is 120 kilometers per hour, but he traveled on national roads at an average speed of 124.85 kilometers. Né? So if we were to basically round that off to the nearest kilometers per hour, right, we'll find that he actually traveled at 125 kilometers per hour. Okay, so what does this basically tell us? Né? If you basically take this 125 kilometers per hour and you minus that by 120 kilometers per hour, you'll find that he actually drove 5 kilometers per hour higher than the speed limit. Okay, so we can basically make the conclusion that he did not keep to the national speed limit. He drove 5 kilometers per hour above the speed limit. So therefore, he did not keep to the national speed limit. He drove 5 kilometers per hour above the speed limit. All right, and then finally, guys, let's have a look at the last question, and we are basically done with this question, right? The last question says that the fuel consumption of Coach Maxwell's car is 5.9 liters per 100 kilometers. Okay, so his car basically consumes 5.9 liters per 100 kilometers. Okay, so you can also just write this as like this: 5.9 liters is equal to 100 kilometers. Okay, so his car consumes 5.9 liters per 100 kilometers. Okay, and the fuel tank capacity is 45 liters. Verify whether it is necessary for Coach Maxwell to refuel at any of the stops he made on his way to Bloemfontein, and you need to basically show all calculations. Okay, so we basically at this point need to determine how many liters of petrol does he consume when he basically travels from Cape Town to Bloemfontein. Okay, we already know that the distance from Cape Town to Bloemfontein is 999 kilometers. Okay, so now using this 999 kilometers, we need to basically determine how many liters of petrol he will basically go through as he travels to Bloemfontein from Cape Town. Okay, so how are we going to do this? We are basically going to take, we already know that 5.9 liters will cover you for 100 kilometers, right? And then we already know that he basically travels 999 kilometers from Cape Town to Bloemfontein. We want to determine how many liters of petrol he will basically need to travel to Bloemfontein, right? So we're basically going to be using this conversion to help us determine how many liters of petrol he basically will need. Okay, so how will we do that? We will multiply by what you want, okay, which is the liters, which is 5.9 liters. Okay, we need 5.9 liters per divided by what you have, which is your units in kilometers. So we're going to divide that by 100 kilometers, okay? So what do we notice is happening here, right? The units for kilometers and kilometers are canceling. And if you punch that into your calculator, you will get your answer in liters. Still, the memo has a mistake here. The memo basically had your answer as I think 5,880 894.1 liters. Okay, so that's what the memo says, but you're supposed to basically get 58.941 liters. Okay, because if you literally just punch this into your calculator, this is the value that you're getting. Okay, how did they get to that 5,000? Okay, so if you basically punch that into your calculator, that is the correct value that you're supposed to get. Okay, and that basically tells us that for Mr. Maxwell to travel from Cape Town to Bloemfontein, he will basically need 58.941 liters of petrol. However, we are told that his car can only, or his fuel tank capacity is 45 liters, meaning that his car can only take 45 liters of petrol. Okay, so what does this mean? It means that, okay, if we basically take that 58.941 liters and you minus 45 liters, the value that we get will basically tell us that Mr. Maxwell will have to then refill that amount of petrol for him to get to his destination. Okay, so if you punch it into your calculator, 58.941 minus 45, this will basically give you 13.941 liters. Okay, so to answer our question, will it be necessary for the coach to refuel at any of the stops? And our answer is, so yes, it will be necessary for the coach to refill, okay, because we've already calculated that he will still need 13.941 liters of petrol. Okay, so that is our final conclusion. All right. And guys, we are basically done with this paper. So I'm actually very proud of myself. I managed to do this paper in 1 week, right? Which is something new for me, right? And we are basically done, guys. I hope you guys enjoyed this video tutorial. I hope that I made every single concept easy and straightforward for you guys to understand, right? And then quickly, I'm just going to show you how they're going to mark this question for people that are here for the mark allocation as well. For question 5.2.1, okay, you will literally just get 1 mark for subtracting your kilometers and your final mark for the final mark of 380 kilometers. That is out of 2. 5.2.2, you will get 1 mark for calculating or finding out that the favorable outcomes is equal to 2 and that your total outcomes is equal to 9. Okay, question 5.2.3. Okay, so this question is out of 6 marks. Okay, you will get 1 mark for just adding up the time spent stopping. Okay, you'll get 1 mark for that. You'll get another mark for calculating what the travel time is, or what the time that he spends driving on the road. Okay, you'll get 1 mark for basically substituting the distance and the time into your equation, right? You'll get 1 mark for getting what the average speed is, that it's 125 kilometers per hour, right? And you'll get a final mark for the final conclusion that you've basically given, that he did not keep to the national speed limit. He drove 5 kilometers per hour above the speed limit. And the last question, how would they mark this question, right? You'll basically get 1 mark for multiplying the 999 kilometers by 5.9 liters divided by 100. You get a mark for that. You get a mark for getting the liters, that is 58.941 liters. Okay, you get another mark for subtracting the 58.941 liters minus 45 liters to get that it's 13.941 liters that he will still need, right? And then you'll get a final mark where you're basically saying that yes, he basically had to refuel. Okay, all right, and that is it, guys, for today's video tutorial. We are finally done with paper 2, guys, and I'll see you guys on my next video tutorials. That is it, guys, and I'll see you guys on my next upload, Distance Learning with Lee, where I make learning mathematics super easy. Bye, guys.